The vast frozen expanse of Siberia is becoming a place of increasing interest for scientists. Enormous craters, some hundreds of meters wide, have been appearing suddenly on the Yamal Peninsula. Initially perplexing scientists, these craters sparked intense speculation about their origin. However, a more plausible explanation has emerged, one that is closely tied to the phenomenon of global warming. These craters are a consequence of thawing permafrost, the permanently frozen ground that lies beneath much of the Arctic. As temperatures rise, this frozen ground is beginning to thaw, releasing long-held secrets. The Siberian craters serve as a powerful visual reminder of the profound changes occurring in the Arctic due to climate change. They are a warning that the consequences of climate change are not limited to distant ice caps or faraway islands. The sudden appearance and the material surrounding the crater indicate that it was formed by an explosion. Since then, scientists and locals have discovered more craters. These craters are huge, some up to 50 meters deep, and they release methane gas. According to a new study published in the journal Geophysical Research Letters, the authors suggest that a combination of the region's unusual geology and climate change triggered the methane release, leading to an explosion, IFL Science reported on October 1st. Anna Morgado, a chemical engineer at the University of Cambridge, and her colleagues suggest that the warming surface leads to rapid pressure changes deep underground, causing a violent release of methane gas. There are only two ways to create an explosion. Either a chemical reaction occurs and you get an explosion like when dynamite explodes, or you pump up a bicycle tire until it explodes. That's physics, said Julian Cartwright, a geophysicist at the Spanish National Research Council. The craters in Siberia show no signs of chemical reactions, meaning they were formed by a physical cause. The pump, in this case, is osmosis, the process of liquid moving to balance the concentration of solutes in it. The Yamal Peninsula has a thick layer of permafrost that usually acts as an osmotic barrier, but climate change has changed that. The permafrost layer, 300 meters thick, lies beneath a surface layer called the active layer. While permafrost is always frozen, the active layer thaws and freezes seasonally. In some places on the peninsula, there are special unfrozen layers of water within the permafrost with high salinity called cryopeg. They remain liquid due to pressure and salinity. Below the cryopeg is a layer of solid methane, crystalline water called methane hydrate, which should be stable due to low temperatures and high pressure. But now, as average temperatures rise, the active layer is thawing and expanding downward until it reaches the cryopeg layer due to osmotic pressure. Because there is not enough space in this layer to contain the additional meltwater, the pressure begins to build up. The pressure causes cracks to appear and gradually run up to the surface, leading to a sudden pressure drop at great depths. That sudden pressure change disrupts the methane hydrate below the cryopeg, leading to the release of methane gas and causing a physical explosion. The research team concludes that the process leading to these explosions could take decades, consistent with the rise in global temperatures since the 1980s. This could be a rare phenomenon, but the amount of methane released could have a major impact on global warming, Morgado said. To understand these craters, it's important to grasp the significance of permafrost in the Arctic ecosystem. Permafrost, ground that remains frozen for 2 consecutive years or more, acts as a massive underground storage system for organic carbon. This carbon originates from dead plants and animals accumulated over millennia. Rising temperatures are causing the permafrost to thaw, awakening this long-dormant organic matter. As permafrost thaws, microbes decompose the organic matter, releasing gases like methane and carbon dioxide. Methane, a potent greenhouse gas, possesses a much higher heat-trapping ability than carbon dioxide over a shorter time frame. Thawing permafrost creates a vicious cycle, releasing more methane and further accelerating global warming. This dangerous feedback loop has the potential to significantly amplify the effects of climate change. The craters in Siberia are formed through a dramatic manifestation of thawing permafrost. As the ground warms, ice within the permafrost melts, creating underground cavities filled with methane gas. Over time, the pressure inside these methane-filled cavities builds up, leading to a massive explosion. This explosion creates the craters observed in Siberia. Some craters are large enough to swallow a house, while others are deep enough to reach groundwater, creating small lakes. The sudden and violent nature of these events highlights the volatile nature of thawing permafrost. These craters are a tangible reminder of the vast amounts of methane trapped beneath the Arctic permafrost. As temperatures continue to rise, such events could become more frequent and widespread. Methane is a potent greenhouse gas, playing a crucial role in regulating Earth's temperature. While carbon dioxide is often considered the primary driver of climate change, methane is about 84 times more effective at trapping heat than carbon dioxide over a 20-year period. The release of large quantities of methane from thawing permafrost has the potential to significantly accelerate climate change. This can lead to rising sea levels, more frequent and intense heat waves, and shifts in precipitation patterns. Thawing permafrost and the subsequent release of methane represent a dangerous feedback loop. As the planet warms, more permafrost thaws, releasing more methane, which further accelerates global warming. This cycle has the potential to push us past climate tipping points, leading to irreversible changes in Earth's climate system. The appearance of the Siberian craters is a stark reminder that climate change is not a distant threat, it is happening now. The Arctic is a critical region in the fight against climate change. The future of the Arctic is intertwined with the future of the planet. The fate of permafrost will play a decisive role in determining the trajectory of global warming. Addressing the challenges posed by thawing permafrost requires a multifaceted approach. Reducing global greenhouse gas emissions through a rapid transition to clean energy sources is essential. In addition to mitigation efforts, adaptation strategies are crucial to help Arctic communities cope with the impacts of thawing permafrost, such as damage to infrastructure and changes in traditional ways of life. The Siberian craters are more than just geological anomalies. They are potent symbols of the interconnectedness of Earth's systems. Their appearance is a stark reminder of the urgent need to address climate change. Understanding the processes that lead to the formation of these craters is crucial for predicting future events. By studying these craters and the dynamics of thawing permafrost, scientists can gain valuable insights. The Siberian craters are a clear message from the Arctic, urging us to heed the warnings of a changing planet. The time for complacency has long passed. The future of the Arctic, and indeed the planet, is at stake.